Hey guys, I'm just going on here because it's the first day of notes. So this is the first set of three sets of notes for the next 3 days of notes about reasoning. Reasoning is really important in geometry, and you are going to be challenged continuously on your reasoning. Remember, I talked about the whole dominoes thing? It's like, why did they give me this? That's really what you always need to be asking. Why did they give me this? Or what can I do with this information? Okay. If they ask you, basically, they're asking you to get to D, but maybe they start at A, and then you have to figure out, well, what does A give me? And then it knocks over B, and then B knocks over C, and then knocks over D. You have to keep looking for these bits of information. So there's a lot of searching for information, and there's a lot of logic, and logic is like an if and a then. Logic is if Judy wakes up at 8, then she will catch the bus. Okay, that's a statement. That's called a conditional statement, which we'll talk about in a second. But the logic part of it is that they say, okay, Judy woke up at 9. What can you what can you determine? Well, she didn't catch the bus, because if she wakes up by 8, she catches the bus. And then they'll say, oh, well, Judy woke up at 7. And you're like, oh, she caught the bus. Like, that's the kind of stuff. It's like evaluating these truth statements. And that's what this section of notes is about. I am not testing you on this section. The pie slice is the grade for this section, just because it can be pretty challenging for some kids. And actually, I don't feel the need to test it. We're going to head into lines at the end of the week, so on Thursday. So, all right, here we go. I'm going to go ahead and shut myself off so you don't have to see me. All right, here it says, there's a thing called in math called sequences. Sequences are just sequences of numbers, like, they come in a sequence. Sequence just means one after the other. There's one called an arithmetic, and there's one called the geometric. Arithmetic, you don't actually have to know this, but it is kind of helpful. Arithmetic means that you're going to add something, okay? Then there's another one that's called geometric series, and that is where you multiply. Multiply. Okay, so let me turn my thing here. Okay, so most of you actually have this one done, but I needed to start with the basics before we get to the harder one and to have a contrast. So when you look at this series, they're like, okay, what are the next two terms? Here's your directions. Find, circle the verb. What are you supposed to find? The next two terms of this sequence. This is a descriptor, okay? It's actually a prepositional phrase if you know that of is a preposition. All right, the first three terms of an arithmetic sequence are as follows. Now your job is to find the next two. Okay, so you have to figure out, what did they do? So arithmetic is kind of like a little clue to you. So what you're doing is you're finding the difference. There's a way of looking at sequences and looking for the difference. Okay, sorry, I need to adjust this thing. Okay, difference. So you're looking between, so you have negative 21, negative 16, negative 11, and we're looking for these two. Okay, so what is the difference between these two? Well, to get from negative 21 to 16, you had to go down 5. So you subtracted 5. Let's see if you got it right. Look at the next set. Look, from negative 16 to negative 11, yep, we subtracted 5. Therefore, to get to the next one, we subtract 5 again, and we will get negative 6. Okay, and then, and I shouldn't say we're subtracting 5. That was totally a mistake, you guys. We're actually adding 5. Sorry, my bad. I was thinking, like subtract 5 in my head kind of thing, but we're really adding 5. You know that, right? Negative 21 plus 5 is negative 16. In other words, we're moving to the right on the number line. Okay, plus 5 is negative 1. So those would be your answers. Okay, and like I said, most of you already have those done. So I'm not really telling you anything that you don't know at this point. Most of you, it's just, I want you to know that when it says arithmetic, if you're paying attention, you would add numbers. This one says geometric. Okay, geometric is multiplication. So it says find the next two terms of this sequence. Okay, so we have 4, we have 20, and we have 100. So the question is, how did they get from here? So even if you didn't know what geometric meant, you could try to add and you'd be like, oh, plus 16. Well, this is obviously not plus 16. So it can't be adding. Okay. How else could you go from 4 to 20? You could multiply by 5. Well, check it. Does it work with the next one? Indeed, it does. So therefore, the next two will be multiplied by 5 times 5. Oops, that isn't where I put it. I put it here. Times 5, and then multiply this times 5, and you would get 2,500. Okay. Later on in the notes, I'm actually going to give you an opportunity to practice. So like this one right here, I'm going to do this one and give you a moment. I'm not going to pause what I'm going to pause enough to tell you to pause your video so that you could try it. Okay, I'm going to do 2 problems. One I'll do, the other one I'll give you just a second to pause your video and you try it and then check to see if you got it right. Okay, it says find the next terms of a geometric sequence with signed numbers. So this one, oddly enough, most people haven't done. Okay, it's 10, -30, 90. Now, like I said, if you didn't know geometric multiplication, you could be like this. Well, how did I get from 10 to -30? Well, I subtracted 40, right? Well, to get from -30 to positive 90, which that made a really cool little square. Sorry about that. That's weird. All right. You would have to add like 120. That's silly. So obviously, it's not arithmetic. Okay. How else could you get from 10 to -30? How about multiplying it by a -3? Okay, this one again. Look, if I take -30 and I multiply by -3, indeed I get 90. Okay, the way you actually find it, the official way to do this, you guys, is to take this term, and divide it by the one that came before it. That gives you your factor. I don't think anybody really needs to do that unless they get really hard. Like if they have some weird fraction one, okay? I haven't seen that happen except for in more difficult books than Alex. So the next 2 terms would be taking 90 and multiplying it by -3. 9 times 3 is 27, add the 0 and the negative. Then multiply -270 by -3. Again, 3 times 27, that's 81. Add the 0. Okay, those would be your next 3 terms. Okay, so now you can pause the video now and you try this one. I'm not going to use this. All right, so hopefully you tried it. Let's see if you got it right. -2, 6, -18. Obviously, it's not adding. Multiply by 3, multiply by 3. Okay, by -3, sorry. -2 times -3 is a positive 6. Positive 6 times -3 is -18. So again, we're going to be multiplying by -3. So -18 times -3 is positive 54. You'll notice that when it's a negative number, it alternates signs. Okay, times -3, and you will get whatever you get. 3 times 4 is 12, carry the 1, 15, 16, 162, negative. Be careful with the signs. See how they alternate? Negative, positive, negative, positive, negative, positive. All right, next. Now we're getting into some logic stuff, okay? This feels a lot like English if you ask me, because it kind of is English. Okay, we're reading English and we're determining whether or not it's true. Okay, the difference is that that kid in the class that always is like, there's always one in every class. Sometimes there's more. When you're like, hey, you guys, you say something like, let's see, tomorrow your homework's going to be due, and they're like, tomorrow's a Saturday, and you know that, like, oh my god, like everybody knows it's a Saturday, everybody knows I meant Monday, right? You always have somebody who's looking for the accuracy. Well, this is that's beneficial when you're doing geometry, super beneficial, because you're always looking for that exact truth. so to speak. So, for each sentence, determine whether it's a statement. So, in this case, this is just a statement. A statement is a basically you are stating a fact. Like a statement is in math, this is a statement. X is 4. Why? Because there's the equal sign, which means the word is. X is 4. See, you're saying what it is. Sally is tall. Got it? It's a sentence. A sentence with a subject and a verb and something that you're defining. See how we're defining Sally. Sally is tall. We're defining X. X is 4. Wow. Okay, that's not a statement. That's just an exclamation. So no. Do your homework. That's not a statement either. That's a command. Okay? Not a statement. No. Okay? Who is your best friend? Sorry, but I'm thinking like who. If you ever heard of Who's on First, that whole comedy sketch, this is a question. It's not a statement. A statement is not a question. We're not questioning anything because it can't end with a question mark. 4 divided by 8, or is that, wait, 4 divided by 8 is 7? Okay, I'm going to tell you that this is a statement, but it is not true. 40 divided by 8 is not 7. Okay, but this is a statement. Okay, they are saying something. Vietnam has the largest population in the world. Yes, indeed. They are defining Vietnam. Okay, so you try. Okay, here's the second problem. Go ahead and pause it so you can try now. Okay, you're basically looking for the verb is or are, to be honest. I mean, when you're defining, get my cell phone from the table. That is a command, not a statement. The water temperature is 75 degrees Fahrenheit. That is a statement. They are defining the water temperature. All squares have 3 sides. That is a statement. I know it's not it. There's no is, but there's a have. Okay? Hey, no. 16 minus 4 is 15. Yes, that's a statement. Again, it is incorrect, but it is a statement. Okay? We're not validating, we're not verifying the truth at this point. Okay? That will come next. Okay? Well, maybe not next on this slide, but I mean like next, like after. Okay? Identifying simple and compound statements. So this makes me think of like, do you know what makes a compound sentence, right? The words and, or, right? Things that bring things together. I feel like conjunction, junction, what's your function? If you guys have ever seen that one from Schoolhouse Rock. Okay, a compound statement has 2 statements, more than one. Okay, so there's a simple and compound. Simple is one, compound is more than one. Okay, so Frank is quiet if the movie is playing. Okay, this is compound because look, Frank is quiet. And if the movie is playing. Now, it does say if it is compound, so I should read the directions first. It says for each statement, choose if it is simple or compound. If it is compound, choose which type. So again, in these notes, you guys should always look at the explanation and copy down the notes, okay, to help you because it's a lot of definitions in the beginning of geometry, a lot, okay? This happens to be a hypothesis, okay? It's a conditional. I think that's what they're going to say. This is a conditional statement. A conditional statement has an if then situation. If Judy gets up by 8, then she will take the bus, okay? If I buy red chili, then I will make enchiladas, whatever, that kind of thing. It's an if then, okay? You can actually switch these sometimes if the movie is playing. Well, never mind, we're not going to do that. That'll happen later. Okay, so yeah, this is a conditional, okay? Bicycles and motorcycles have 2 wheels. simple or compound. And it's simple. Even though the subject is more than one, okay? We have one verb. Bicycles and motorcycles have two wheels. It's one statement, okay? My favorite sandwich type is peanut butter and jelly. Again, it's simple. Why? Because there's one verb. Doesn't matter that there's two things that are on your sandwich. It's one sandwich, okay? All right, let's go ahead and try the next one. You try this one, okay? All right, let's try this one. The crew will paint the house blue or green. What do you think? I'm wondering if I did this one wrong. You guys need to tell me. Go back. Hang on. Ooh. Bicycles and motorcycles have two wheels. I'm wondering if this and makes this compound. Can you guys let me know? I don't know. I feel like I'm answering it English-wise, which makes sense to me. And my inclination is that that is not a compound. But let me know. You're going to need to actually look at the notes in these sections too, because there are, I can't pull down these drop down menus from my Alex. Okay. The crew will paint the house blue or green. In my opinion, this is a compound because it's or. Okay. In other words, the crew will paint the house blue is one condition. The crew, or they'll paint it green. Okay. This is an or compound. I don't remember what they call that. Sorry. I wish I should have marked this down. My favorite sandwich. You know what? The thing with Alex, they repeat this stuff. Okay, this is simple. The cat will come out if and only if you sit very still. This is absolutely, definitely compound. You guys will let me know about this one. Okay, the cat will come to you if and only if you sit very still. So do you see there's two different things that are happening here? Okay, the cat's going to come out and you have to sit very still. Okay, if and only if is called a biconditional. When you see the words if and only if, that means it is true all the time. Like it means that you can actually go in both directions. Like that it is true for both ways. Like the cat will come to you if and only if you sit very still. If you sit very still, oh, wait, okay. If you sit very still, right? If only as a cow. I'm sorry. I'm having trouble with English flipping this thing around. We don't need to flip it around right now. Okay. You need to know that it's biconditional. Usually it makes sense English wise, but this is weird. If you sit very, no, okay. Sit very still. No, it doesn't. Okay. Just leave me alone. Okay. Just, yeah, I'm just like having my own little complication here. You guys, you're fine. All you need to do is choose simple or compound and choose which one. Again, check the explanations to try to get these words. If there's more than conditional, if there's more than biconditional and conditional, conditional is the if then situation. Okay. You want to get those notes down. All right, let's try the last one. Negation. Oh, this is second to last one. Negation of a statement. Negation means to like counteract, basically. Negation is like no. Okay, if you want to think of it that way, negation means to negate it. It's like Sam's gonna eat a hamburger. Sam's not gonna eat a hamburger. That's the negation. Okay, negation means you say you basically undo what's been done, like you negate it. Okay, so it says there are several statements in the table below for each determine whether it's a negation of this statement. Okay. Here is the statement right here. You might miss it if you're not paying attention, you guys. Seriously. Like sometimes the way they organize it, you're like, wait, what happened? Okay, it's right here. Okay. So it says, it is not the case. The not stuff can be really tough in English, you guys. So you just have to sometimes say it slower and think about what it means. Like put yourself in the situation. Like it is not the case that the sign is on the table. Case in English has two words. It could mean like an actual suitcase, or it could mean like a situation. In this case, it means situation. It is not the situation that the sign is on the table. Okay. It means the sign is not on the table, correct, you guys? Okay. It is not the case that the sign is on the table. All right. The sign is not on the window sill. So is this a negation of this? Okay. Does the fact that the sign is not on the windowsill, does that negate this? And the answer is no. It's not even talking in the same like realm there. Oh, look, I left it on highlighter. That's funny. Okay. The sign is on the table. It is not the case that the sign is on the table. So in this case, the sign is not on the table. So the negation is that the sign is on the table. Yes. It is not the case that the sign is on the bookshelf. Does that have anything to do with this? No. Okay. The sign is on the bookshelf. Well, that has to do with that one, but not this one. Okay. It said of this statement. So the answer to this would be no. Okay. Nobody asked us where the sign was. All they asked us to negate it. Okay. Judy is eating ice cream. Judy is not eating ice cream. That's the kind of negation. However, they do give you weird English. Like sometimes they give you some strange English constructions. So you have to kind of think about them. Okay. All right. Here's the one for you to practice. So go ahead and pause it and try it. All right, I'm going to go ahead and do it. There are several statements in the table below. For each, determine whether it is a negation of this statement right here. X is equal to 200. That's it. X is equal to 200. Is this a negation? X is equal to 400? No. That just tells you a different situation. X is not equal to 200. Yes, that is the negation. X is not equal to 400. That has nothing to do with our situation. It is not the case that X is equal to 200. Think about that for a second. X is equal to 100. It is not the case that X is equal to 200. The answer to that one is yes. They're just giving you practice with this weirdo English. Weirdo English. Okay, it is. It's strange. All right. Nobody talks like that. It's just not the case. I mean, unless you're in some old English, maybe. I don't even know. Okay. Sherlock Holmes book or something. All right, here we go. Conditional statements and negations. This is the last one. Okay. And I think this is the most important thing. This is where the whole like kid in the class that always has to tell you that it's Saturday and not Monday. Saturday, yeah, not Monday. That's this stuff right here. Okay. Consider the following statement. The water temperature is 60 degrees Fahrenheit. Okay, you got to be that person that's paying attention to this. It says the water temperature is 60 degrees Fahrenheit. Think about that. We know exactly what the water temperature is. It's 60 degrees Fahrenheit. Check all the statements below that are negations. Okay. The water temperature is less than 70 degrees. Okay, now that's true, correct? But does it actually verify or do the opposite of the water temperature is 60 degrees Fahrenheit? And the answer is no. Okay, so that is not a negation. You can tell it's not a negation when you can think of an example that fits this one. That's true for this, but not true for that. For example, 69 degrees is less than 70, but it's not the temperature, or it's not like this could be many other things. If the water temperature is 60 degrees Fahrenheit, the negation means that it's not 60, correct? So we're looking for anything that says negation is looking for not 60. This is the symbol for not 60. Okay. So we're looking for not 60 degrees Fahrenheit. Okay. Well, 69 is not 60 degrees Fahrenheit. Okay. But it's also not negating it directly. Okay, it's giving you many more examples. All right, so it is not the case that the water temperature is 60 degrees Fahrenheit. See, it is not the case. That is true. And that is true. The water temperature is not 60. That's what we need. We don't need some little kind of close thing. Okay. If Ravi's spouse is happy, then Ravi is in France. Think about this. It's a conditional statement because it has an if and a then. That means basically that this is called the hypothesis. Okay, if you have a conditional statement, I will give you these notes. It's an if and a then. I already told you that. The if part is the hypothesis, and the then is the conclusion. Okay, the hypothesis comes first. So if Ravi's spouse is happy, then Ravi is in France. Okay, that's all we know. Okay, that's the condition that we know. So what is the hypothesis of the statement? This is the hypothesis. So let's find it right here. Ravi's spouse is happy. If they had asked you for the conclusion, you would have put Ravi is in France. Okay. If they would have asked you to validate the truth of it, that's a whole different problem. Okay. And that will be coming up. Okay, ready? You try this one. And this is the last bit of notes today. Okay. The sign is on the table. Negations. The sign is not on the table. Boom. Yep. Sign is on the table. Sign is not on the table. A plant is on the table. Who cares? It has nothing to do with our sign. It is not the case that the sign is under the table. See how it doesn't match? So that is not a negation. If it is Friday, then I get home before 8 p.m. I get home before 8. Okay, so if it's Friday, I get home before 8. What is the conclusion of the statement? It's okay, so it is Friday. No, that's the hypothesis. 7, no, doesn't match. I do not get home before 8 p.m. No, does not match. I get home before 8 p.m. There you go. Okay, a little bit of logic for you. And that's it for these notes.